Hi, I hope you are doing awesome. So the question we are seeing today is remove leaves in a generic tree. So suppose we are given this generic tree and we need to remove all the nodes which are actually leaves, and leaves are the nodes which do not have any children. Suppose. So as we know that the generic tree class has two things. First one is node and the second one is an array list called children. Right. So if the size of this array list is actually equal to 0, that means that this node does not contain any children, and hence it is actually the leaf node. But before we actually move on to the solution, I have a request that please do not skip this video because it contains very sensitive things about array list and trees, and which approach of recursion we actually have to take. So if you skip the video, you'll miss out things. So it's my request, kindly don't do that. Right. Okay. So let's see in this generic tree, which are all the leaves. This 20 is a leaf, this 50 is a leaf, this 30 is, and this 70. So we need to remove these, these nodes because they are leaf nodes. Now, I have to take recursive approach for firstly. So there are two type of approaches. The first one, let's say post order, and the second one is pre-order. Right. In a post order approach, what I do is I have a faith that my children will shed their leaf themselves. Right. And after my children have shed their leaves, what I'll do is I'll shed my leaves also as a root node. Right. So if 10 has faith that 20, 30, and 40 will get their leaves shedded, and similar approach for 20, 30, and 40 when they become the root node. And what happens is, so suppose I get the faith for 2. So 20 will get the get the call, then after that 30, then 40, then after that 50. 50 does not have any children, then 60, then after that 80. 80 does not have any children, 70 does not have any children. So the call moves up. Right now, as the call moves up, 30 has a child which is leaf. Suppose I somehow get known that this is leaf, so 30 will remove this, then 60 will remove 80, and 40 will remove 70. Then after that, when 60 has already removed 80, 60 is now become a leaf node because it does not have any children, and 30 will see 60 as a leaf node and it will remove it too. And after this level, when all the children have removed their leaf nodes, 10 will get all the children as leaf nodes only because they already have removed their leaf nodes. So they themselves have become leaves. Now 10 will remove everything. And when the program goes to the post order of 10, 10 will also come out to be a leaf node because it has already shed all its children. And hence 10 will also remove, and my all of my tree will be vanished. Right. So I cannot actually use this post order approach. I need it to be pre-order approach, right? So let's see how pre-order is going to work. Actually, what I'll do is as 10. Okay, let me clean this tree a bit, right? Let me clean this tree a bit. Yeah. So as 10, what I'll do is I will see that which of my children are actually leaves. So 20 is a leaf. I'll remove 20 and I'll now pass on the work to my children, right? Only 20 was leaf, so I'll now pass on the work to the children. So the 10 never gets a chance to remove the leaves in the post order, because if it does, it will shed the children which were actually originally not leaves, right? So let me show it in the code. Let me show it in the code. Okay. Where did I actually write it here? Here. So my call goes like this: for node child in node dot children. We first need to identify that if suppose that if my child is a leaf, right? But this loop won't be working because when I try to remove something from an array list using this for each loop, it will actually give me an error of concurrent modification because I am traversing through the same array list and I'm removing from the same array list. So that's not possible. So what I need to do is I need to run a for loop. For int I equals to 0, I is less than node dot children dot size I plus plus. But there is an error in this one also. Suppose, let me show you the error, right? Suppose I had an array list which was 10, 20, let it be 1, 4, 7, 12, and 32. Right. Now what happens is, let's say the task at my hand is that I need to remove all the even elements of the array list, right? So I'll check first. This one is, if one is even, I'll remove that. Otherwise, I'll move. Now, let me also take the index I equals to 0. 1 was checked. I was moved forward. Now I is 1. Is 4 an even number? So yeah, it needs to be removed. 4 gets removed and I becomes 2. But as my 4 gets removed, my new array list becomes 1, 7, 12, and 32. And I is now 2, where 0, 1, 2, 3. 2 is actually this element. So if you see that 7 never got tested, right? 7 never got tested because we were at 4 here, and after that we straight away jumped to 12. And this is a problematic situation. Suppose instead of 7, if I had 8, so 8 wouldn't have ever been tested, and after the loop was exhausted, I would still have the even elements left. So there is a problem, right? The solution to it is that if we if we run the loop from the backward direction, see, suppose it's 1, 8, 4, 12, and 32, and let's take one more element, 9. If we move the loop from the backward direction, that is size minus 1, we check it. If it's even, we remove it or we move forward. So actually in this direction, right? Now 32 gets removed, okay, and my loop gets forward. It doesn't have to, it doesn't have to do anything in the backward direction now. So even if these elements move forward, it doesn't impact the working of my loop, right? Because after, it'll still check 12, it'll still check 4, it'll still check 8. So the solution of this is run the loop in backward direction. Let's see. Okay, so I is equals to node dot children dot size minus 1. I is greater than equal to 0 and I minus minus. What do I have to do is, let's take it node temp is equals to node dot children dot get I. Now I have this temp. I'll check that if temp dot children dot size is equal to 0, that is if temp is a leaf node, right? What I'll do is I'll node dot children dot remove, that is temp. I'll remove the leaf. After that, after this being done, what I'll have is I'll run my faith that all my children will be able to do the same working, right? So for node child in node dot children remove leaves child. So let's run this program. It should hopefully run. So it's getting accepted. Let's try to submit it now. So it's getting submitted, and it taught us many important concepts, like why we are actually doing the working in pre-order and not in post-order, right? Why we are actually running the loop from the backward direction, not from the forward direction. And also why we didn't use the for each loop, right? So meditate over things which I taught you in this video. And if you like the explanation, kindly hit that like button and subscribe to the channel. Thank you very much.